And this is one of the things that I still use anytime that I want to figure out on my check how much taxes they're taking away from me, or how much that I'm getting out of my check. Okay, I'm going to use this process. So what we're going to do is, basically we're going to set up a proportion. So what's a proportion again? It are ratios that are equal to each other, right? And so when we solve those in second section, we learned that we are going to do it with cross multiples, right? So we would have had, as Addison just said, two ratios. And basically, if we just put in A, B, C, and D, we would have taken where one of those four letters would have been the actual letter, and then we would have replaced the other letters with numbers. And then we would have just done our cross products and divided by that third number, and we would have gotten an answer. So basically, we're going to try to set up this again and then solve those proportions like we solved before. All right, so we're going to do a lot of the same thing that we've already done. It's just the process of actually getting it there. Okay, so what you got to remember now is we just talked about percents. When we did percents, what did we always base everything off of in a percent? 100, right? So one of my ratios is always going to be shown as the percent over 100. So what the percent meaning, they're going to give you a percent, or they might ask you to find the percent, but it's always going to be put over 100 because of what we just got done talking about. Every percent is based off of 100. So then the next fraction that we're going to talk about, there's a couple different ways that I can envision this, but a lot of the times they call these is over of problems. So they're going to have a number that's around the word is and a number that's around the word of. But it's usually, and I want to say usually because it's not going to happen every time, it's a number right after those words. One of those two words. And so basically you're going to be given a sentence. And you can think of it as they're going to use the words is and of in that sentence just about every time. So another way of doing this, so this would be the exact same thing. We're just going to say it in a different manner. So we're still going to have the percent over 100. The other way that you can think of it is the part out of the whole. So what's the whole thing that we're talking about? And then what percentage or a part of it would go on the top. So either way, exact same thing, exact same method, exact same math we're going to do. It's just how your melon wants to listen to it or figure it out. Okay? So we're going to set up this proportion every single way. And it's basically going to be the same.
What do you do with these though?
We'll see.
What do you mean? What do I do with it?
Like, how do you get your answer to these?
Well, one of these four or one of these other three spots are not going to be given to you. So you're looking for one of those three spots. I'm either looking for the percentage, or I'm looking for the part, or I'm looking for the whole. So basically, like I said, I would use this to figure out, I know what I got for my check, I know what my grand total for my check was, and then I would figure out the percentage that they took away from me. You know what I'm saying? Okay? So, they're going to give you this as a sentence. So, 20 is what percent of 25? So, do you notice now the words, or is and of in there? So, in this case, if we look at this as 1, 2, and 3 every single time, what am I trying to find in this particular problem?
The percent.
I'm trying to find out what percent, right? So when I write my proportion, I'm looking for that percent. Now, if you don't want to put a percent sign there, you put a variable. X, M, whatever you want. So the other two numbers that they give me, though, are the part that's going to form my other ratio. So again, I'm going to look at those two words, is and of, and like I said, it's usually the number right after those words, but obviously in this first one, it's a contradiction, right? It's the number right before. So again, what you have to remember is sometimes in another example, the percent might be after the word is, and so by what I told you at the beginning, it's always the number right after that word. But if it's the percent, it always has to be the percent. So the percent can't go in any other spot in the proportion. That makes sense what I'm saying there? Okay, so in this fraction right here, what do you think we should put?
20 over 25.
20 over 25. So the biggest thing here is that you make sure that you set it up right. And now if I have it set up right, I'm ready to find the percent. And if I don't see or know what that is right offhand, then I have to do the math. And now we're right back to section 2 again, right? So do my diagonal, multiply diagonally, and then divide by that third number. Or if you know 20 out of 25, what percent is that?
80.
80%, right? So either do 100 times 20, and set that equal to 25x. And then I'm basically going to divide by 25. Now this one's probably just easy, so you didn't really have to do that. But this gets you that same percent.
Don't you, when you're, or am I going too far, like when you, try to find like, percent of a number, like 8.8%, you take it, you turn the percent into the decimal, multiply by the
You can do it that way too. Because you're essentially fast forwarding the process. You're doing the process, but you're dividing by 100 right away. And we'll show you that in this next one. But you're exactly right. Okay? So that one was easy because we could basically do that problem in our head, right? So let's get numbers that we can. So what number is 8.8% of 20? So this is one right here where the numbers and the percentage is surrounding that word of. So again, which number is the of? Well, again, if it's the percent, it's got to be the percent. It can't be any other portion of my problem. So, what am I going to put? Do I have the is? No. So I'm going to put x, or you can use the word is, I don't care. And then what goes below x?
20.
Everybody agree?
Yep.
Okay? What goes on the denominator of the second one?
100.
Always 100, right? And the percent goes above 100. So we get 8.8%. So what Mr. Colbeck was asking is this right here. Essentially, I'm going to do this diagonal again, just like we did in section 2, multiply and then divide by that third number, right? Well, he said, can I just move the decimal 2 places to the left and then multiply? Essentially, it's the exact same thing, right? Because if I took this times this and divided by 100, I would get my answer. He's just dividing by 100 basically first and then multiplying by that same number. You're going to get the exact same answer every single time. It's just how no one kind of thinks about it. Okay? So, anybody do the math?
Yeah.
What do we get? X equals
1.76.
1.76. Everybody else agree? Now here's the other thing that you got to think about. Okay? Should this number right here in this first ratio ever be bigger than this number down here? Should the is ever be bigger than the word of?
It can.
When?
If you're trying to find something that's larger than like if it's 120 over 100.
Exactly right. So the only time this number is bigger than this number of is if my percent is over 100%. If it's under 100%, the top number should always be smaller than the bottom number. So again, anytime from here on out, and we struggle with this all the time when we're doing business math. If you hear the word rate or percentage, you should always end up with a decimal. So the smaller number should always be on top of the bottom number, or the smaller number should always be on top and the bigger number on the bottom. So when I divide, I always get that decimal to turn it into a percent. But again, a percent and a rate are the same things a lot of times. Okay, so keep that in mind. All right? Everybody okay with 1.76? All right, so let's try this one. Try setting up and doing this one all by yourself. 70 is 28% of what number? So again, set up your proportion. That's the main thing right now. And then solving your proportion, hopefully we're getting okay at that. But if you don't set it up right, you can never get it right. And then at the end, make sure that it makes sense. And this section, honestly, you can use a calculator a little bit more instead of trying to do the math all the time. Okay? So first things first, what proportion did you write down?
So it's 70 over X equals 28% over 100.
Anybody disagree with that proportion?
No.
Everybody get that part?
Yeah.
That's the main part, right? So now we're taking this times this divided by 28, right? So 7,000 divided by 28 is?
250.
So then again, the last thing that you should really think about is, does it make sense? Should I get a rather large number here if I'm only talking about 28% of it? Yeah, probably. If this is closer to 100, then, you just got to think at the end, does it make sense? If I'm at 98%, these two numbers should be relatively what? Close to each other. Exactly right. But if I'm at 6%, these numbers should be really far apart from each other. Make sense?
I found, for when you're trying to find the bottom, you just do the exact opposite way instead of the way I did it, where you took 0.88 times 20 and then you got your answer, right? You just divide it by that number in decimal form.
Yes. Right. You're just eliminating one of the steps. But essentially, you're doing that step anyway because you're dividing by that number. So you do it, you just don't really show it.
So basically when I said that, the only time it can go higher is like an example would be like the profit of something.
Yeah.
Like if you got
Right. Or if I had extra credit, or if I had, if my production was higher. So if we do that, we could say 80 is 120% of what number? Right? If I did it this way, now I know that 120 over 100 has to always be in the one fraction. 80 would be where, the top or the bottom? Top. 80 is. So again, it's around that word is. So 80 goes on top and X on the bottom. But now my answer, X, should be what compared to 80? Smaller, right? Because the top number should be bigger because it's over 100%. So what's 8,000 divided by 120? Somebody punch it in their calculator. 8,000 divided by 120.
6
.6.
right? So then again, at the end, we would look at it and say, all right, we don't know if we're exactly right, but it at least looks like we made sense, right? Okay? Questions there? It's a really important concept. We'll do this a couple days because this is important to be able to set it up every time the right way. Okay? So, we can also do this with story problems. We all love story problems, right? So again, when you go to the story problems, it probably makes more sense to do this second one or to relate it from the part to the whole. Because not all of the story problems will use the words is and of. So that's why it's kind of important to understand both of the concepts being the same thing. Okay, so here we go. From the years 1988 through 1996, Steffi Graf won the U.S. Open 5 times and Wimbledon 7 times. What percent of both tournaments combined during those years was she the champion? So first off, everybody understand what this is talking about? What are we talking about in this? What sport is this? Tennis. Okay. Steffi Graf is a tennis player. Okay. So how many times does the U.S. Open and Wimbledon happen in a year? Once each, right? So first off, we got to figure out how many times did the tournaments combined happen between our time frame. So from 1988 to 1996, first off, how many years is that?
8 years. Oh my gosh.
How many?
8.
I said 8. He said something else.
Okay, so everybody agree 8? Everybody good? Why do you say 8? Why do you say 8?
8? Because it's 1988 to 1996.
Okay, now watch. 1988, 89, 90, 91, 92, 93, 94, 95, 96.
Oh, because counting that year. Oh,
Right.
fine.
So, here's the thing. When you're asked from here on out, this is really important because a lot of people do the same thing. You guys just subtract it, right? And essentially, that's what you got to do. But when you're talking about years and you want to include both, you have to subtract and add 1 every single time.
Because you have to include that same year.
Right. Well, you have to include the year at the beginning and the year at the end. Okay? That's really, really important. So, in this case right here, how many times did those tournaments happen? Combined.
18.
18, right? Because we had 9 years and there's 2 tournaments. So there's 18, right? So, set up the problem. What percent of both tournaments during those years was she the champion? So, set up the problem. Using this right here. Don't say anything out loud. Try to do it. So, 18 is my what? Or the of, or the whole, right? All right? So, we're trying to figure out what percentage. So, first thing again, what is our formula or our proportion?
12 over 18.
12 over 18 equals,
X over 100.
everybody agree or disagree?
Where's 18?
Okay, remember how many years we had? 9, because I proved that to you. There's 2 tournaments per year, so 9 times 2 is 18. Okay, because the U.S. Open and Wimbledon happened each of those 9 years.
She was a really good tennis player.
She's really, really good, yeah.
She won 2/3 of the time.
2/3. Does that make sense now? Yeah. Okay. So then we just do our math, right? Or if you would know what this is, but how many?
66.6%.
66.6% of the time. So again, make sure in these problems, if you're looking for this portion of our proportion, make sure you always put a percent sign. Okay? Read the next one. At middle school, 600 students were asked about recycling. 32% said they did newspapers and cans, 25% just cans, 19% just newspapers, and 24% said, heck no, we don't do it. How many families recycle both cans and newspapers? Set up your proportion and solve.
I have a funny one.
So again, make sure you read the portion that you need in this case. So we're thinking about the proportion that we're going to set up. And what pieces of that proportion do we have? You don't know? So obviously, I'm going to help you out here. Need my help?
I mean, it's just that, it doesn't make sense, but that's what I got.
Wait, which one, are we using the bottom? I know. No,
All right, so
Oh, the bottom.
what don't we know?
the amount of family.
We don't know the is or the part, right? Okay, so X goes here. How many families do we have? 600, right? At a middle school, 600 students were asked about it. So we're assuming that all of the students that we asked, yeah, only child. We don't have any siblings in that school. Weird, huh? Okay, so what goes up here though?
32.
Why 32?
Because that's the amount of
That does both, right? That does both. So this is where it'll get a little bit more complicated when you get older in math, because then you'll have to do like a combination kind of thing. Figuring out, okay.
No.
Yes. Okay, so we're not to that, but that's where it'll end up being, okay, in Algebra 2 and stuff. So now we're right back to doing what we wanted though, right? This times this divided by 100. So what'd you come up with?
192.
So I don't know why it didn't make sense, but 192 would make sense, right? 32% is roughly a third of our students. So is a third roughly 192?
Yeah.
Right? 200, 200, 200 would be a third.
I got 30. I don't know.
Did you do this?
Well, not the way you did it.
Well, you gotta.
What did you do?
I kind of messed up, I think, and that's what got me.
Did you do the new math?
Yeah, stick to my math instead of.
I mean, I was doing what I was.
I know, but a lot of the times, your new math, you and Kanai start doing new math, and then you confuse yourselves with the new math because you're like, oh, this is really cool, oh, it works, oh, and then you honestly forget how you got the new math to work the first time
No.
because, oh, my old boring way always works.
I don't do
I
new
did
math.
point
I just
32
find
times
out
600.
the real math.
Yeah, but
Wow.
like I said, then you forget your method sometimes, and then you get confused. Mm-hmm. Yeah.
Oh, yeah, I did something wrong.
We know you did.
No,
Okay.
No.
So,
I did that in my calculator, and I got the right answer.
blame the calculator.
Yeah.
All right, so questions here.
It wasn't in my calculator. I did it in my, I did it on my paper, but I did it on my calculator, and I got it. And yeah, it was right.
All right. Are we good with this? Like I said, really important concept. We'll practice this again when we come back next week. But this is really important, and both of these are exact same thing. Is over of or part of the whole. But we're going to go cross products. And it's always a percent over 100. Every single time. And again, that's why we had to do last section, right? To determine that or convince ourselves that it's always out of 100.
In the book, which one is he gonna use? Is and of or part and whole? Or does it not matter?
Both.
Oh, they're gonna use both.
They're going to use both.
Okay.
To me, like right up there, to do is over of probably doesn't make as much sense in a story problem because they're not going to necessarily use the words is and of. But these problems will all have is and of in them.
Yeah.
So you can still think, instead of this saying what number is the part of the whole, but they're going to always use is and of in these kind of problems. Then when they get to the story problems, I would turn to the part of the whole. And we'll do that a little bit when we start doing like discounts and sales tax and stuff. That's when, next week when we come back.
I see what I did wrong. I forgot to add the 0 at the back of like the tens place. Like, you know, I just add a 0 on the number. Yeah, and I didn't do that.
It's a big deal, isn't it?
Yeah, give me.
People don't think that that little 0 makes that big of a difference, but oh boy, does it.
I was off by
So basically,
about
in number two, when you
162.
get like all those 4 numbers you're gonna have to find, are they gonna have